Hello everyone, welcome to the next lecture on point clouds and 3D mesh models. When drone images are processed using photogrammetry, one of the most powerful outputs generated is the point cloud. From this point cloud, software can then create another important product known as a 3D mesh model. These two outputs form the foundation of 3D mapping and modeling in drone surveying. Let's understand how they work. What is a point cloud? A point cloud is a collection of millions or sometimes even billions of individual points in 3D space. Each point represents a specific location on the surface of the terrain or object that was captured during the drone survey. Every point in the cloud contains important information such as x coordinate, which is east west position, y coordinate, which is north south position, and z coordinate, which is elevation or height. In many cases, millions of points are viewed together. They form a highly detailed three-dimensional representation of the surveyed area. Point clouds are generated when photogrammetry software analyzes overlapping drone images and calculates the exact 3D location of visible features. Why point clouds are important? Point clouds provide an extremely detailed digital representation of real world environments. Surveyors, engineers, and planners use point clouds for tasks such as measuring terrain elevation, analyzing building structures, calculating volumes in mining operations, studying landforms and infrastructure. Because point clouds contain so many data points, they allow professionals to analyze environments with very high levels of precision. What is a 3D mesh model? While point clouds are powerful, they still represent surfaces as individual points rather than continuous shapes. To make the model easier to visualize and analyze, photogrammetry software converts the point cloud into a 3D mesh model. A 3D mesh is created by connecting nearby points with small triangular surfaces, forming a continuous digital surface. This process transforms the point cloud into a solid structure that represents the shape of the terrain, buildings, or objects. Adding texture to the model. After the mesh is generated, the software often applies texture mapping. This means that the original drone images are wrapped around the 3D mesh to create a realistic visual model. The result is a photorealistic 3D representation of the surveyed environment. How these models are used. Point clouds and 3D mesh models are used in many industries, including construction site analysis, mining and stockpile measurements, infrastructure inspection, urban planning and architecture, environmental monitoring. These models allow professionals to visualize complex environments and perform accurate measurements in three dimensions. In simple terms, point clouds provide the raw 3D data while 3D mesh models convert that data into a smooth and realistic surface representation. Together, they play a key role in modern drone surveying and aerial mapping. In the next section of this course, we will begin exploring drone mapping software, which is used to process aerial images and generate all these powerful mapping outputs. Thank you and see you in the next lecture.